Let's continue with our look on periodic trends. So let's consider an atom's attraction for additional electrons. The attraction of an atom for an electron is called electron affinity. The same factors that affect ionization energy also affect electron affinity. In general, as electron affinity increases, an increase in ionization energy can also be expected. So in other words, metals have low electron affinities and nonmetals have high electron affinities. Although electron affinities are not quite as regular a pattern as ionization energies, they still show periodic trends. If we look at a column or a group on the periodic table, we're going to see that the general trend as we go down a group is a decreasing tendency to gain electrons. We would expect this trend since the atoms farther down the column are larger. As a consequence, the nucleus is farther from the surface and the attraction of the outer electrons is less strong. So when we look at electron affinity, it's the energy change that's associated with the addition of an electron to a gaseous atom. And we can write an equation for that. We've got a gaseous atom X. When we add an electron to that gaseous atom, we're going to form a gaseous negatively charged ion or anion. When we talk about the sign for the energy, it's defined as the energy change when an electron is added. So if the process is an exothermic process, energy is being released, and the sign on our value is going to be negative. So what's our trend? As we go down a group, what happens to electron affinity? Generally, it becomes more positive or less favored as we go down a group because we're farther and farther away from the nucleus. Electron affinities become more negative or more favored as we go from left to right across a period. And there are some exceptions, more exceptions than there were for ionization energy. Now let's deal with electronegativity. And it's a measure of the element's ability to attract electrons in a particular bond. And again, looking at a graph, we've got atomic number along the x-axis. We've got the electronegativity value, or the attraction of electrons in a bond, along our y-axis. And we're going to see again a clear-cut pattern that arises. As we go across a period, our electronegativity increases. So if we were to look at our yellow dots, we can see an increasing trend, and that's period 1 or period 2. If we were to look at our red dots, again we've got an increasing trend, and that's period 3, and so forth down. So as we go across a period, our electronegativity increases. As we go down a group, we would possibly look at the dots at the top of each of those curves, and we would see that the electronegativity decreases. So looking at a periodic table, as we go down a group, electronegativity decreases. As we go across a period, it increases. And we want to talk a little bit about why, and it's related to size. Again, as we go down a group, the electrons are farther and farther away from the nucleus. There's more shielding. There's less of an effective charge, so there's a less attraction for electrons. As we go across a period, we're adding more and more protons to the nucleus, but we're in the same energy level, so the shielding is about the same, the effective charge increases, and the attraction for electrons goes up. Another trend, although this isn't as much of a trend as others, is the metallic character and the phase of the substances. Density tends to increase as we go down a group, so you're tending to be more liquids and gases towards the top of the periodic table and solids more towards the bottom. And also, if we were to look at a particular group, towards the top of the group is more non-metallic, towards the bottom of the group is more metallic. So think about nonmetals. Nonmetals tend to gain electrons. And if we're towards the top of the group, there's less shielding, so the attraction for electrons is greater. As we go down a group, the effective charge decreases, so the ability to lose electrons is greater. So to sum up some of our periodic trends, as we go towards the top and the right of the periodic table, your atomic radius decreases. And as you go from bottom left to top right, your ionization energy and electronegativity both increase.